Good day, viewers. In this virtual class, we're going to look at this integral before us. Find the integral cos x sin x dx. Here we are looking at integrations. Okay, and we're going to look at this question and see the techniques or the method that will be more appropriate, to use in order to resolve these questions. Here, we're going to make use of integration by algebra substitutions. By first letting either cos x or sin x to be another function. So that's what we're going to look at here. And the next step is to make find the derivative of that function and make it dx in that function as a subject of the relations, then before substitutions. Okay, now let's go into operations. I'll say let u is equals to sine x. If u is sine x, our integral is now reduced to cos x times u dx. Okay, here we differentiate u with respect to x, and this become the u with respect to x become differentiate sine, it becomes cos x. Here we make the s subject of the relation. So if we multiply both sides by dx times dx, here we have the u, okay, is equals to cos x dx. Because we are trying to make the s subject of the relation, we will divide both sides by cos x, divide both sides by cos x, and this will be off, so that dx is equal to the u divided cos x. So we come to this our function here, and in place of dx, we will substitute the u over cos x. What we are trying to do is that we are trying to get rid of x, since we have let u is equal to sine x. That is the essence. Okay, here we say here this is an integral of cos x times u. We already know that ds is now the u over cos x. Now, looking at this clearly, you will see that cos x and cos x here, they are already off, and our function integral is now reduced to integral of u du. Okay, and we know that if we have an x raised to the power n, integral of x raised to the power n dx, the formula is x raised to the power n plus 1 divide n plus what? 1. So if that is applied to integral of u du, this integral becomes u raised to the power 2 over 2 plus c, where c is an arbitrary constant. So we can now say that the integral of cos x sine x dx is equals, because we have already said that let u is equals to this, we say this becomes sine square x divided by 2 plus arbitrary constants. Okay, we can leave our answer like this, or we can also further express is that we know that sine square x is equals to 1 minus cos square x. Okay, we can either put this in place of this, and we still have the same answer. Okay, we want to verify if our claim is right. Okay, let's differentiate this, whether we will obtain this. Okay, then in that case, we say let y is equal to sine square x all over 2 plus arbitrary constants. Here, what techniques of differentiation do we need to use for this? We're going to use what we call this is a composite function, or we call it a function of a function. So here we can say that y here is equal to sine square over 2. Here we can say let u is equal to sine x, so that y is equal to what? U square over 2. Okay, and what we need to do here is that for us to obtain our dy dx, dy dx from function of function simply means du or dx times du ds times okay, du ds times dy all over du. Okay, this is the function of function. So by the time we du, we go with du, we'll obtain the y dx. Okay, and here du with respect to the x, if we differentiate this, it's going to give us cos x, where the y over the u here is equal to 2 times u, 2 minus 1 divided by 2. This go off, so that our dy over the u is equal to just u. Okay, that is the case. Our dy dx, as we have rightly said, is the product of the u dx times the y du. Okay, now if that happens, we've known that the y du is u, and what is u? We have said let u is equal to sine x. So this is sine x, and the u ds is what? Is cos x. Okay, this shows that our workings, our derivative is absolutely correct. So here, this is how to to resolve an integral of this relation. Once you know that one of the functions can be expressed as the other one, all you need to do is dot integration by algebra substitution. Okay, that's how we resolve such an equations. Please, all you help me do, you can help me subscribe to my YouTube channel, Algorithmatics, by clicking on this link, so that when the more important videos of this nature comes out, you should be able to have access to them. Have a nice time. See you in my next virtual class.